So here we go again, and let's continue our lesson about the third kind of conic section, which is ellipse. So on our previous lesson, we discussed the standard form of equation of an ellipse when its center lies on the origin. We discussed about the two orientation of an ellipse, about horizontal ellipse and vertical ellipse, but this time we will discuss, or we will find, the equation or the standard form of equation of an ellipse when its center does not lie on the origin. But before that, let me introduce myself. I am Mr. Mario Aquino Jr., teacher in senior high school, major in mathematics, teaching pre-calculus. And for our objective, we will going to find and also graph the equation of an ellipse when its center does not lie on the origin. So we will have another form of standard of equation of an ellipse, and also we will discuss the equation of an ellipse having horizontal major axis and vertical major axis. So before we go to our main lesson, let us have some recalling about summary of meanings of some required values that we were going to use to find the equation of an ellipse when its center does not lie on the origin, and also help us to graph the equation of an ellipse. So we have summary of meanings of A, B, H, and K, and also the value of C. So first, the center of an ellipse when it does not lie on the origin, the coordinates, we will set the coordinates of its center as H, K, and the vertices are A units from the center on the major axis. The endpoints of the minor axis are B units from the center. So the endpoints of the major axis are called the vertex, while the endpoints of the minor axis is called co-vertices. And for the last, the foci are C units from the center on the major axis. So again, the value of A is the distance between the vertex or the vertices from the center, and the value of B is the distance between the endpoints of the minor axis, or called co-vertices. The distance between the co-vertices from the center is B, and the value of C is the distance between the foci or one of the focus to the center. So that is the summary of meanings we should know before we start our main lesson. So our main lesson for today is about standard equation of an ellipse, but this time the center does not lie on the origin, or the center of the ellipse does not lie on the origin. So we will have another two standard of equation of an ellipse for this lesson. The first orientation if we have horizontal ellipse. The second one is if we have vertical ellipse. But how will we know if the given ellipse is a horizontal ellipse or vertical ellipse? So there are many ways to know if we have horizontal ellipse or vertical ellipse. First, if we give an equation of an ellipse and simply analyze its form of equation, we will easily know, or we will easily determine if it is horizontal ellipse or vertical ellipse. But how? So notice on the horizontal ellipse, we have this kind of equation, and in this part, we call it as the x part, and this part is the y part. So let us recall the value of A and B. The value of A is the distance between the vertex, one of the vertex, to the center, and the value of B is the distance of one of the covered vertex to the center, and we also know that A is greater than B. So therefore, A squared is also greater than B squared. So if we have an equation of ellipse and we see the x part, the denominator of the x part is greater than the denominator of the y part, the orientation of ellipse is horizontal ellipse. On the other hand, if we have greater denominator on the y part than the denominator of the x part, we have vertical ellipse. So another way to see if we have horizontal ellipse or vertical ellipse is by simply seeing the graph of the ellipse. So I will discuss it further as we go on the lesson. So I will discuss first the horizontal ellipse. We will find and graph the equation of an ellipse given its vertices and foci. So this is the equation we will going to use for that. And as I said earlier, another way to see if it is horizontal or vertical ellipse is by seeing its graph. And the graph of the horizontal ellipse is this one. This one is the origin, and this one is the center. If we have a horizontal major axis, that is our hint that the graph of ellipse that is showing for us is a horizontal ellipse. So let's go to our first example. We need to find the equation of the ellipse with the given vertices and foci, then graph the equation. So this is the vertices and the foci. The first thing we need to do is to plot these points on a coordinate plane. So let us plot these points. So first, we plot the vertices. So the vertex 1 and the b sub 1 is -4, -2. And the second vertex is 6, -2. So plot those points. And next is foci. We have f sub 1, -2, -2. And f sub 2, 4, -2. Plot those points. And we have that one. And next, the center will be the midpoint of the line segment joining the vertices and also the foci. Thus the center will be 1, -2, and the line segment is our major axis. And we need to find the value of A, and to find the value of A, we know that the value of A is the distance from the center to the vertex, and the vertex is 5 units away from the center. So therefore A is equals to 5. The next is to find the value of C. We need to find the distance from the center to one of the foci or one of the focus. In this case, one of the focus is 3 units away from the center. So therefore C is equals to 3. So we have the value of A, we have the value of C, we have the value of H and K because we have the coordinates of our center. So to find the value of B, we need to use the formula of B squared is equal to A squared minus C squared. And by substituting the value of A and C to this equation, and as we solve this one, we will get the value of B, which is 4. And now, to graph the equation, we need first to construct the major axis and also the minor axis. To construct the minor axis, we all know that the value of b is the distance between the center and the one of the endpoints of the minor axis. So this is the minor axis, and then we will next construct the major axis. And the endpoints of the major axis are the vertices. And after we construct the minor and the major axis, we can now construct our ellipse. So that's how you graph an ellipse. So next, we will going to find its equation. To find the equation of an ellipse, we need this information: the center, the value of a, and the value of b. Since the vertices are horizontal, the ellipse is horizontal, and we will going to use this formula by simply substituting the required values, which is h, k, a, and b. We will going to have the equation of an ellipse, which is x minus 1 quantity squared over 25, which is a squared, plus y plus 2 quantity squared over 16 is equals to 1. So for vertical ellipse, we will also find and graph the equation of an ellipse. And the graph of a vertical ellipse is this one. And we will know that the ellipse is vertical by simply seeing its graph when it has a vertical major axis. And the equation we were going to use for that is this one. So let's go to our second example. We're going to find the equation of the ellipse with the given vertices and foci, then graph the equation. The given vertices is negative 3, negative 4, negative 3, 6. And the foci, the given foci is negative 3, negative 2, negative 3, 4. And again, the first step is to plot these points on a coordinate plane. So first, graph the vertices. We have these vertices, plot these points, and next is plot the foci. The foci is that, and next is to find its center. And we all know that the center will be the midpoint of the line segment, which is the major axis, joining the vertices and also the foci. So our center will be negative 3. It's located at negative 3, 1. So again, to find the value of a, so the value of a is the distance from the center to our vertex. At this case, the center is 5 units away from the vertex, therefore a is 5. So again, to find the value of c, and we all know that the value of c is the distance from the center to one of the foci or one of the focus. And this time, one of the focus is 3 units away from the center, so c is 3. And to find the value of b, we use the formula of b squared is equal to a squared minus c squared by simply substituting the value of a and c to this formula or to this equation. We will have the value of our b, which is b is equals to 4. And to graph the ellipse, as I said earlier, we need to construct first its minor axis and the major axis. So this is the minor axis. We all know that the value of b is the distance from the center to one of the endpoints of the co-vertices or the endpoints of our minor axis. And then construct the major axis, and then for the last, construct our ellipse. And that's how you graph a vertical ellipse. The next is to find the equation of a vertical ellipse. So again, the necessary information we need to use to find the equation of a vertical ellipse. We know that since the vertices are vertical, the ellipse is vertical, and the equation we're going to use is this one. And by simply substituting the required values, which are h, k, a, and b, we will have the equation for our vertical ellipse, this one. So for the last, we need to discuss the problem. This problem, we need to find the standard form of the ellipse given by this equation. So how will we going to find, how will we'll be able to find the equation or the standard form of equation of the ellipse given by this equation? We need a series of algebraic steps in order to find the standard form of equation of ellipse by this equation. So first, we need to arrange and regroup the like terms to this equation. So we will going to have this one. So this group, we will call it as the x part, and this one will be the y part. So this is the y part and this is the x part. So on the x part, we're going to factor out 9, and on the y part, we will going to factor out 16. And the equation will become like this. So it will become 9 quantity x squared minus 6x plus 16 quantity y squared plus 2y is equals to 47. So now, x squared minus 6x. This x squared minus 6x need to become a perfect square trinomial, and also y squared plus 2y need to become also a perfect square trinomial. But how? By simply follow the idea of adding and subtracting suitable terms, the equation will become like this. So will become 9 quantity x squared minus 6x plus 9 plus 16 quantity y squared plus 2y plus 1. So if you notice, we add 9 to the group of the x part, and we add 1 to the group of the y part. So on the idea of addition property of equality, it is said that what you add on the left side, you need to add also that value on the right side for the equation to be balanced. So on the x part, we add 9 inside the group, but if we distribute the 9 coming from the outside, this 9 here will become 81. So on the x part, we add 81. So what we add on the left, we also add it on the right, so plus 81. So on the y part, we add 1. So if we distribute 16 on this group, 16 times 1 is 16. So we add 16 on the y part, which is on the left side. So we need to also add 16 on the right side. So that's why 47 plus 81 plus 16. So the equation now is already balanced. So to continue this one, we need to, from perfect square trinomial, we need to factor this out. So x squared minus 6x plus 9 will become x minus 3 quantity squared, and y squared plus 2y plus 1 will become y plus 1 quantity squared. We need to divide both sides of the equation by 144. So the equation will become like this. And by simplifying this equation, we're going to find the standard form of equation of an ellipse, which is this one.